Continuing with our work on derivatives, we already know that the derivative gives us the slope of the tangent line at any point. So we're going to look at this graph and try to estimate values of f prime by drawing tangent lines and estimating their slope. Then we can find, of course, the equation of a tangent line, because that's always fun to do. So let's start with when x is negative 7. So that's over here. If I draw in a tangent line, remember it has to touch at one point, and I found a ruler. So I can try to get a good, and this is an estimate, so I'm going to try to make it line up pretty nice. Needs to go about that way. So here we go. Kind of touches at one point. And that looks like it's approximately, looks like about 4. Is the function, the graph, increasing or decreasing, or is it a maximum, relative max or a relative min at that point? Well, my graph is going up, so that's increasing. Equation of the tangent line, well, we need the point of tangency, which is negative 7 comma negative 3. And we need the slope of tangency, which we said was about 4. So to keep things nice and easy, we're just going to use point slope, y minus the y value, equals the slope times x minus the x value. And that's our equation of the tangent line. When x is negative 6, that looks like it's a little bit over, not as steep, maybe right there. Could be about a 2. And is the function increasing or decreasing? It's increasing still. Point of tangency. The x value is negative 6, the y is 0. And we believe the slope of tangency is about a 2. So y minus the y value, slope, x plus 6. Let's do f prime of negative 4. What's happening at negative 4? Oh, if I draw a tangent line, that is what I get. So that's about 0. And right there, I have what is called a relative maximum. Point of tangency. So when x is negative 4, the y value is 2. And the slope of tangency is 0. So y minus 2 equals 0 times x plus 4. In other words, this is y equals 2. When x is negative 2, let's see what we got there. Get my ruler out. It's about, oh, that's kind of nice. I think if I draw it in there, it almost looks like it's a nice negative 1 slope. So f prime at negative 2 would be approximately negative 1. And at this point, the graph has started decreasing. Point of tangency is going to be negative 2, and the y value was 1. Slope of tangency, it says about negative 1. So I have y minus 1 equals the slope times x plus 2. When x is negative 1, it gets a little bit harder there. At that point, this line is tangent. Now, is it hitting the graph somewhere else? Yeah, it is. But right at that point, it is tangent there. So that's f prime of -1. Looks like it's about a slope of -2. The graph is still decreasing. Point of tangency would be -1, comma, -1. And we said the slope of tangency was about -2. So y minus my y value, slope, times x minus my x value. When x is 1, ooh, right there, my slope is 0. And that point would be considered a relative minimum. So let's write our equation. Point of tangency, x is 1, the y value was -4. The slope at that point was 0. So I can still write it in point slope. College Board doesn't mind. But that also could be written as y equals -4 because it's a horizontal line. When x is 3, let's see, when x is 3, I'm about there. That looks good. That looks like about a +3 slope. And right there, the graph has started increasing again. The point of tangency, when x is 3, the y value was -1. And we said the slope of tangency is about a 3. So y minus my y value equals the slope times x minus 3. When x is 5, let's look at the graph. Ooh, easy one. Horizontal. So f prime of 5 is about 0. And that is another relative max. Point of tangency. When x is 5, it looks like my y value is 1, 2, 3, 4. Slope of tangency is 0. So you're welcome to write it in point slope or recognize that that's a horizontal line at y equals 4. When x is 7, ooh, graph is going down again, isn't it? It's about there. That looks like a -4 again. Oops, you can't see that. F prime of 7 looks like it's about, that'd be a -4. And at that point, my graph has started decreasing again. Point of tangency. When x is 7, my y value is -1. The slope of the tangent line was about -4. So I get y plus 1 equals the slope times x minus 7. Based on this, what can we infer about the derivative and the behavior? Look at all the times the graph is increasing and what the slope is. Look at all the times it's decreasing and what the slope is. So I'll be kind of reviewing this in class, and I hope you can kind of come up with some rules. We'll add them in class. What about finding the slope when you have just points in a table. So estimating the derivative at 0. Well, to estimate the derivative, we're going to have to use points on either side. So to estimate the derivative at 0, I need to use the points around 0. So I'm going to be using this point and this point. So to estimate the derivative, I'd have to find the slope around that point. So y minus y, so negative 3 minus 2 over 1 minus negative 3. And that gives me a negative 5 over 4. From what we were learning, what do you think this means about the function? You can even tell by the point values. This y value is 2. We went to 1. Then we went to negative 3. So what's happening? It's decreasing. What's the equation of the tangent line? The point of tangency at 0, the y value is 1. And we said the slope is about negative 5/4. So y minus 1, negative 5/4 times x minus 0. To estimate the slope at 1, we're going to have to use this point and this point. Because we have to basically use a secant to estimate the slope of the tangent line. So y value 0 minus 1 over 4 minus 0. That gives me negative 1 over 4. Let's see what's happening. So if I've got a negative slope right there, what has just been happening to get from 1 to negative 3? Well, it had to have decreased still, right? So at negative 3, it's been decreasing. We have a point of tangency. So when x is 1, the y value is negative 3. Slope, we said, was about negative 1/4. So I get y minus a negative 3. And then the slope, x minus 1. At 4, so for 4, I'm going to be looking between here and here. So to estimate the slope of the tangent line at 4, I'm going to have to use the secant line that's going between this point and this point. So I'm going to go negative 7 minus a negative 3 over 6 minus 1. Okay, so that's negative 4 over 5. And that at that point, what's happening? Well, if you've kind of noticed the pattern, whenever the slope is negative, that means it is decreasing overall. Because between negative 3 and negative 7, it's decreasing. Point of tangency is 4, 0. And the slope, well, slope of the secant line, technically, is negative 4/5. Approximately. What about estimating at 6? We'll have to take the points that surround it. Y minus y, x minus x. So to approximate the slope at 6, I'm going to have 2 minus 0, and then 10 minus 4. That's 2 over 6, which is about 1/3. So I've gone from 0 to 2, which means this one is increasing. Point of tangency is going to be 6, negative 7, The slope of the tangent line is approximately 1/3. 2, 6, 1/3. Y minus -7, 1/3, x minus 6. We're going to save the rest for class.